A quick way to determine the number and type of solutions that a quadratic has is to calculate the equation's discriminant, and we'll compare that to 0. So the discriminant is just a number, and we calculate that using the coefficients in the equation, and then we'll compare that number to 0. Is it greater than 0, equal to 0, or less than 0? That will tell us how many solutions and what type they are of the equation. So the way we do this, the way we calculate this number, is once our equation is equal to 0, just like solving for factoring a quadratic formula, once it's equal to 0, we plug b, a, and c into this part of the quadratic formula, the b squared minus 4ac. That number is the discriminant, just the b squared minus 4ac. All right, and then we'll compare that number to 0. So let's look at this first example. Right now, it's not equal to 0. It's equal to -10. So let's manipulate the equation so that it is equal to 0. So that's going to turn it into -4x squared minus 7x minus 9 equals 0. All right, once it's equal to 0, that's what we want. So now we're going to plug a, b, and c into the discriminant, which is the b squared. So -7 squared minus 4 times a times c. And we're going to compare that with 0. All right, and then looking over here, we can compare it to the table, and that'll tell us the number of solutions. So if we simplified this left side, we would get 49 minus 95. And I don't know exactly what that is, but I know that that's going to be a negative number, so that is less than 0. So since the discriminant is less than 0, that means that I'm going to have 2 imaginary solutions. So 2 imaginary solutions. All right, so that's all you do. You plug the a, b, and c into the discriminant, b squared minus 4ac, and you compare that to 0. That will tell you the number and type of solutions. It doesn't tell us what they are. It just tells us the number and the type. All right, so if you look at this next example, same deal. If it's equal to 0, we can go, but it's not. We need to move the 9 over. So -9 minus 9 is -3x squared minus 2x equals 0. So b squared minus 4ac. Let's see, b squared would be -2 squared minus 4 times a times c is just 0. Comparing that to 0. Well, -2 squared is 4, and all of this stuff, since it's times 0, is 0. So how does 4 compare to 0? Well, 4 is greater than 0. So since the discriminant is greater than 0, that means that there are 2 real solutions. Right? 2 real solutions. Yeah, you can throw in there the word real versus imaginary solutions. All right, so 2 real solutions. Because the discriminant was greater than 0. Well, in the last example, if you can't already guess what's going to happen, same deal. We're not equal to 0 yet, so let's make it equal to 0. That's going to give us 2x squared plus 4x plus 2 equals 0. So we'll plug that into our discriminant. So b squared minus 4ac. Compare that to 0. That's going to be 16 minus 16. Well, that's 0, and 0 equals 0. So if your discriminant equals 0, what does that mean? That means there's just one real solution. All right, so just one real solution. All right, so that is the discriminant. It's a way to tell the number and type of solutions. Now, another thing we can do with the discriminant is to find a value for our equation that would produce desired solutions. So in other words, if I've got this little equation and I want to know what c value would force this thing to have two imaginary solutions. All we have to do is set up our discriminant equation and find what C would equal to make it be whatever relationship with 0 we want it to be. So, for example, I want two imaginary solutions. That means I need my discriminant to be less than 0. That will cause the two imaginary solutions. So, all I do is let's write our discriminant. So b squared minus 4 times a, and a, b, c. So b squared minus 4ac, I need that to be less than 0. So now this is just a little equation we're going to solve, and it'll automatically tell us what c would have to be to cause these imaginary solutions. So that's 36 minus 8c is less than 0. So we'll just subtract the 36. So negative 8c is less than negative 36. So c would have to be, since we're dividing by the negative 8, that's going to flip our inequality sign. So c is now greater than positive 36 over 8, which would reduce to 18 over 4, which would reduce to 9 halves. So c is greater than 9 halves. All right. If c was greater than 9 halves, again, that would guarantee that my equation would have two imaginary solutions. All right. Why don't you pause and try this and see if you do get that c equals, sorry, that c is greater than 1/12.